Hi, everybody. So, in case we had a situation where we didn't get too deep into this, I wanted to make a video to kind of help us get through the lesson and be a good helpful guide for after class. So I'm going to do this first problem together with all of us. All right, so there's some information up top, and we'll make sense of it as we go. So John is riding a Ferris wheel at the Goshen Fair. We time his progress with a stopwatch. He reaches the high point on the Ferris wheel 4 seconds after we begin. Right, that's an important piece of information. And reaches it again 24 seconds later. The lowest point of the wheel is 3 feet off the ground. The diameter of the wheel is 60 feet off the ground. So in a lot of situations, I like to draw my picture out and visually see what I'm going on with. All right, so here's my Ferris wheel. So I'm told in this situation that my lowest point is 3 feet off the ground. Oop, I did not want to erase that. The lowest point of my Ferris wheel is 3 feet off the ground. I'm also told the diameter is 60. So if the diameter is 60, my radius is 30. So from there to there is 30. From there to there is 30. So that's my picture. Now he reaches the high point of the Ferris wheel 4 seconds after the timing. So that's where we are in the Ferris wheel. So by getting that out there, it kind of helps me establish some of my things. Now with our equation, we have to understand, we got y equals a, then we got to figure out if this is sine or cos, b, x minus h plus k. All of these have a quick, easy, reliable way of working with this problem. A is always going to be the radius of the wheel. Right? A is always going to be the radius of the wheel. K, up top, we got the K. It says max plus min divided by 2. I like to think K is the midpoint of the wheel. Right, it's the midpoint of the wheel, and we take into consideration how far off the ground, plus the ground distance. Right? H doesn't have to exist, but H is a time shift. H is a time shift that gets us to either a high spot, a low spot, or the middle. Right? So H is always going to be a time shift. B, right, is going to be 2 pi divided by the period. Now the period, that is P equals 1 full spin. Right? So it can be from the high point to the high point, from the low point to the low point, to the midpoint back to that same midpoint. So if we analyze this situation here, right, for my Ferris wheel, right, A is going to be 30. Right, our radius is 30. Okay, now, which trig function do we have? Well, here's the key thing. Reaches the highest point. Right, so highest point is telling me it's a positive cos graph, because the graph would look something like this. We're up there at the very top. Highest point, right? Cos graph. Now, what would be the lowest point? The lowest point would be a negative cos graph. So we have lowest point. It's a negative cos graph. If we have the midpoint going down, that's a negative sine graph. If we have the midpoint going up, that's a positive sine graph. Right, so all the wording in this problem kind of leads us to what we need. Right, so we got a highest point, positive cos. Right? Now B. B comes from the full 2 pi over the period. So in this situation, it tells us it takes 24 seconds to get from the high point back to the high point. Right, so our period is 24, which means we have 2 pi over 24, which a little simplifying, pi over 12. Right? H is our time shift. We're told 4 seconds later, they're at the high spot. Now, in these situations, you have to understand that you don't always get on the Ferris wheel at the top, the bottom, or perfectly in the middle. But with our sine and cos graphs, we have to make sure that we're at those top, bottom, or middle spots. So the time shift gets us to the top, bottom, or middle. The last thing is our midpoint of the wheel. So we got the radius plus the distance off the ground for 33. So there's our equation. Y equals 30 cos pi over 12 x minus 4 plus 33, to take into consideration that we're going off the ground. Now, another thing I like to realize is how high the graph goes up. So if I take in the diameter and the distance off the ground, I have 63. So from my sketch here, my graph's going up to 63 and it's going down to 3, right? It's gonna be 3 feet off the ground. All right, so I got my time delay of 4. Let me make a different color here. I got my time delay of 4. It takes 24 seconds to complete that entire curve. So I'm going all the way to 28. My midline is 33. I'm going 30 above it and 30 below it. All right, so there's my box that we always focus on. Now, as we know, we need our start, our end, and our midpoints in between. So if I'm starting with the 4-second delay, 24 seconds later, I'm at 28. All right, so if I add them up, 32 divided by 2 is 16. 16 plus 4 divided by 2 is 10. So I see I'm increasing by 6. 16 plus 28, we got 22. And there's my spots. All right, so for the graph, at 4, we're at the top. At 10, the wheel starts spinning. We go down to that middle. 16, we hit the bottom. 22, back up. 28, we're back at the top. So there's our 24-second spin on the Ferris wheel. We start at the top, we go down, we get to the bottom, we come back up. Now, this is something that we could work with on our calculator. So our calculator can do this problem for us and help set us up so we can figure this out. Because there's some follow-up questions down here. So like the question, all right, what is John's height above the ground 10 seconds after we start timing? So if we're talking about 10 seconds later, we're going from 4 to 14. So on the graph, we could visually see at 14, we're about there. But we need an actual answer. And we can use our calculator to help us out with that. All right, down here it's saying, when does John reach 20 feet? So again, we can look at our graph, see 20 feet. We're talking about 20 feet coming from there and there. Right? We can visually see it, but our calculator can do this for us. So let's look at how we use our calculator to help us out here. All right, so let me bring up my calculator. All right, so first thing first, we got to change our mode. We want to make sure we're in radians. For all these word problems, radians is the way to go. Now, the first page of this worksheet, which we kind of skipped over just to get to this, that was talking about it being in degrees. We're not going to graph in degrees. We're going to graph strictly in radians. All right, so y equals, and we're graphing 30 cos, I'm going to throw my fraction bar in, alpha y equals pi over 12, close parentheses, x minus 4, close, close, and then my midpoint of 33. So there's my equation, 30 cos pi over 12, x minus 4, plus 33. Now, if I just hit graph based off what I have this. So my calculator was set up, whoever set my calculator up has whatever the window is here. Yours may look something different, but in every situation, we have to readdress our window to best meet the needs of this problem. All right, so let me finish this graphing. And now we're going to change our window. All right, so our x minimum or x maximum. So what we talked about is there is a 4-second time delay. So my start for this graph is at 4. It takes 24 seconds to spin the wheel. So I'm going from 4 to 28. With my y minimum, I kind of just go at 0 to focus on the 0 being the ground. The top of my Ferris wheel is at 63, I think we said. 63. So honestly, I don't know. I'm going to go up to 70 to get a little bit of a clearer view. So I changed my x minimum 4, my x max 28, my y minimum 0, my y max 70 to fit this specific problem. So if I hit graph, there's my curve. So slow. All right, there's my one coast graph, exactly what we're focused on. So back to the question, was John's height above the ground 10 seconds after we start timing? All right, so 10 seconds after we start timing, oops, I think I made a little mistake. 10 seconds after we start timing is actually just 10 seconds as I reread the problem. All right, so what we do now is if we hit trace and type in 10, we get 33. All right, so the number I had before, which was, I read the problem a little off. If we try 14, we would have had 7, but we're going with 10. 10 seconds after you get on the wheel, you are at 33 feet above the ground. So it's just trace and type in whatever x value you want. You want 8 seconds? We're there. 9 seconds? We're there. 15 seconds? We're there. All right, so whenever you're getting a y value, give it an x, trace. Easy. Now, given a y value to find x, it's a little bit tougher. We actually have to graph. So we're looking at 20 feet above the ground. So I'm going to graph y equals 20. Right, so again, I visually see my answers. So there they are. And our calculator can tell us what they are. If we hit second calc and go down to intersect, what we do now is scroll over to where those two lines cross. All right, we're looking where the line y equals 20 crosses with our coast graph. And we're going to do the super high-tech method of hitting enter, enter, enter. Intersection, there it is. So by hitting enter 3 times, it tells us that we cross at 11.7 seconds, 20 feet. Now visually our graph, we see it crosses a second time. So we can figure that out here by doing same exact idea, second calc intersect, scrolling over to that second crossing point, and doing yet again the super high-tech method of enter, enter, enter. And we cross at 20.28 this time. All right, now every time you do these problems, you got to change your window. You got to change your window to best fit the problem that you have. Whenever you're doing an x value, we got to make sure that x value is also on the screen. So I can't do second trace. I can't do trace for like 96 because it's off the screen. Right? So my window range is from 0 to 4 to 28, so I can only do trace with numbers between 4 and 28. And so if we go back to the problem, right, so I made that little error before, misreading. So we're looking at 10 feet, we came up with the answer of, at 10 seconds, we're at 33 feet. By using our intersect, we are first there 11.71 seconds, and then we get there again at 20.29 seconds.